The sun has been hammering the deck for 3 days. There is no land. There has been no land since the last volcanic silhouette sank beneath the horizon 90 hours ago. The double-hulled canoe rises and falls on swells that seem to come from everywhere and nowhere. Somewhere ahead, beyond the curve of the earth, sits an island no wider than a few miles. At this distance, it is invisible. At sea level, hidden by the horizon itself. And there is no map. There is no compass. There is no radio. No satellite. No instrument of any kind that a modern person would recognize as navigational technology. There is only the ocean, the sky, and a single human being who must find that speck of land or never return home. This is not a story about luck. This is not a story about desperate guessing or blind faith. What Polynesian navigators accomplished across thousands of miles of open Pacific was something far more remarkable. They built a navigation system out of memory, training, and relentless observation. They read the ocean the way you read a highway. And the fact that you've never heard exactly how they did it is what makes this one of the most underrated achievements in human history. Here's the problem most people don't fully grasp. Imagine you're standing on the surface of the ocean. Your eye level is perhaps 5 or 6 feet above the water. The horizon is roughly 3 miles away. That's it. That's your entire world. Everything beyond that curve is hidden from you. Now imagine the island you're trying to reach is 20 miles wide. Sounds reasonable. Except at 50 miles out, you cannot see it. At 30 miles out, you still cannot see it. You might get within 10 miles and still see nothing but water. Miss your heading by just a few degrees over a voyage of 1,000 miles, and you sail right past. The island was there. You were close, and you never knew it. The Pacific Ocean covers more surface area than all of Earth's land masses combined. Polynesian voyagers crossed it in wooden canoes held together with plant fiber lashings. They found islands separated by distances that would swallow entire European nations, and they did it again and again, intentionally, repeatedly, across generations. If this were luck, the math doesn't work. If this were accident, the settlement patterns don't make sense. Something else was happening here. Something systematic. Something teachable. Something that worked. Most people imagine ancient navigation as a kind of mystical gift. The wise elder stares at the stars and just knows. That image is romantic but wrong. Polynesian wayfinding was not magic. It was pattern recognition trained into the body and mind over years of disciplined apprenticeship. It was observation so refined that it became automatic. And it was a technology not made of metal or glass, but of memory, culture, and practice. Let's start with the stars. On a clear night in the open Pacific, the sky is an overwhelming dome of light. Thousands of stars visible to the naked eye. To an untrained observer, it's beautiful chaos. To a trained navigator, it's a directional map that shifts through the night in predictable ways. Stars rise from specific points on the eastern horizon and set at corresponding points in the west. Every star has its own arc. And crucially, the point where a star rises stays consistent relative to your latitude. This means that if you memorize which stars rise where, you can hold a heading without a compass. Traditional wayfinders organized this knowledge into what researchers sometimes call a star compass. Not a physical object, but a mental model. Imagine the horizon as a circle divided into segments, each segment associated with a particular star or constellation that rises or sets in that zone. If you know your destination lies beneath the rising point of a certain star, you sail toward it. When that star climbs too high to be useful, another takes its place. The sky becomes a rotating schedule of directional beacons. And experienced navigators memorized dozens of these star paths, so that on any night, at any hour, they could look up and know which way to go. But here's what most people miss. Stars alone aren't enough. The sky clouds over. The horizon vanishes. Storms roll in for days. What happens when you cannot see the stars at all? This is where the ocean itself becomes the instrument. Polynesian navigators developed an extraordinary sensitivity to swells. Not the chaotic wind chop that covers the surface, but the long, deep, rolling waves generated by distant weather systems sometimes thousands of miles away. These swells are remarkably consistent. They travel across entire ocean basins with a regularity that wind waves lack, and they come from identifiable directions. A navigator trained from childhood learns to feel the angle of the primary swell against the canoe. That angle becomes a baseline, a constant, a reference. Even when clouds block the sky, the swell is still there, rolling beneath the hull. Even in total darkness, a skilled wayfinder can detect shifts in the swell pattern by paying attention to the pitch and yaw of the vessel, the rhythm of the deck underfoot, the way the bow responds to pressure. Some navigators reportedly lay down in the hull to feel the motion directly through their bodies, filtering out visual distraction entirely. And it gets more subtle than that. When swells encounter an island, they bend around it. They reflect off the underwater slopes. They interfere with each other in patterns that extend outward for miles. A navigator who knows these interference signatures can detect the presence of land long before any visual confirmation. The island itself disturbs the rhythm of the sea. If you know how to listen with your body, the ocean tells you something is out there. Now layer in the wind. The Pacific trades blow with seasonal regularity. In certain latitudes, the wind holds a consistent direction for months at a time. Navigators internalized these patterns deeply. They knew when the trades would shift. They planned their voyages around it. Wind direction, combined with swell direction, combined with star position, created overlapping reference systems. If one system failed, another was still available. The more systems you could read simultaneously, the more robust your navigation became. Redundancy was survival. Clouds, too, carry information. Open ocean rarely has large vertical cloud formations except in one circumstance: land. When moist trade winds pass over an island, especially one with any altitude, the air is forced upward. It cools. Water vapor condenses. The result is a column of cumulus clouds that builds through the day and can be visible from far beyond the range at which the island itself appears. These island clouds are most obvious in the afternoon, when convection is strongest. A navigator might see the telltale stack of white on the horizon hours before the palm trees come into view. And if the island is too small or flat to generate such clouds, other signs may still appear. A greenish tint in the underside of clouds can indicate reflection off a shallow lagoon. A subtle brightening can hint at the presence of a reef. Then there are the birds. Not all seabirds help. Some species spend weeks at sea and tell you nothing about nearby land. But certain birds, particularly terns and noddies, return to land every night to roost. They fly outward in the morning to fish and return home in the evening. A navigator watching the sky at dawn sees birds heading out. He notes their direction. At dusk, he watches them coming back. Their flight path points toward home, toward land. If the birds are flying low and purposeful in the late afternoon, there's a good chance something solid lies nearby. The range of these homing flights can extend dozens of miles, effectively expanding the navigator's detection radius. But you can't see everything from the surface. That's part of what made Polynesian voyaging so ingenious. Navigators had to become specialists in indirect evidence, floating vegetation, driftwood, the debris that accumulates in current convergence zones, phosphorescence at night, where certain organisms glow in disturbed water and can reveal the presence of reefs or shallow areas, even scent. Some islands, especially volcanic ones with vegetation, release a distinctive earthy smell that can carry downwind for miles before any other sign appears. The navigator is always gathering data. He's not looking for one clue, he's looking for convergence. Stars say one thing, the swell confirms it, the clouds are building in the right place, birds are heading back in the late afternoon. Floating branches and leaves are increasing. The direction of drift matches expectations. When all of these signs point toward the same conclusion, confidence builds, not certainty. Never certainty until land is in sight, but informed, calculated confidence that a destination is close. And now imagine that final approach. Days of watching, days of doubt suppressed, days of trusting that the methods are sound. The navigator sees the clouds first, a tall column building on the horizon where nothing was before. The swell pattern shifts in ways that suggest something is interrupting the deep rhythm. Birds appear, moving with direction and purpose toward that same spot on the horizon. The scent of rain and vegetation reaches the canoe, faint but unmistakable. The crew adjusts the heading slightly. Hours pass. The tension is unbearable. And then, just barely, a dark line separates from the water. The top of a palm, a silhouette of volcanic rock, land. That moment is not the beginning. It's the reward for everything that came before. But wayfinding is more than technique. It's also engineering. The canoes themselves were built for this mission. Double-hulled vessels provided stability in open swells and enough deck space to carry crew, provisions, and sometimes colonists with plants and animals for settling new islands. The hulls were lashed together with sennit cordage rather than rigid fasteners. This was intentional. A flexible lashing system allowed the vessel to twist and absorb wave stress that might shatter a rigid joint. The canoes could flex without breaking. They moved with the sea rather than fighting it. Sails were constructed from woven plant fibers, often pandanus leaves, and rigged to allow the canoe to tack into the wind at angles that surprised early European observers. The vessels were fast. Estimates from modern reconstructions suggest speeds that matched or exceeded many European ships of comparable eras. And the canoes could go where no large ship could follow, into shallow reef passes, onto beaches, into the lagoons of islands with no natural harbor. Provisions were calculated with life or death precision. Fresh water was carried in sealed gourds or bamboo containers. Ration discipline was strict. Voyagers knew exactly how many days of water they had and adjusted consumption accordingly. Food stores included dried fish, fermented breadfruit paste, dried banana, and preserved coconut. These supplies could last for weeks if managed carefully. Some voyages also carried fishing lines and the skills to supplement rations en route, but no one relied on catching dinner as a primary plan. Planning was the primary plan. Contingency was layered on contingency. Just as important was the choice of when to sail. Polynesian navigators knew their weather patterns intimately. They understood seasonal wind cycles, the direction of prevailing trades by month, the times of year when storms were most likely. They didn't launch voyages blindly. They waited for windows. They chose their departure based on accumulated knowledge of what the ocean would likely do. And if conditions turned, they had fallback plans, alternate destinations, routes to other known islands, even the knowledge of how to survive at sea until the weather cleared. All of this knowledge, the stars, the swells, the birds, the clouds, the canoe construction, the provisioning, the seasonal planning was transmitted through training. Young navigators began learning as children. They memorized star paths the way modern students memorize multiplication tables. They practiced reading swells in sheltered waters before ever going to open sea. They learned chants and stories that encoded navigational principles into memorable forms. They absorbed the knowledge communally, because no single voyage happens alone. The knowledge belonged to families, to communities, to islands. And it was continuously practiced because voyaging wasn't a one-time stunt. It was a way of life sustained across centuries. There's also a psychological dimension that gets overlooked. Open ocean voyaging is mentally brutal. The monotony of empty horizon for days or weeks erodes concentration. The fear of being lost, the knowledge that a mistake means disaster, the exhaustion of constant watchkeeping, all of it compounds into a pressure that can break a person. Traditional voyaging cultures addressed this with structures. Crews had defined roles and rotations. Songs and chants kept minds engaged. Stories passed the time and reinforced shared purpose. Rituals marked phases of the journey. These practices weren't optional cultural decoration, they were survival strategies. A crew that loses morale loses focus. A crew that loses focus makes errors. And errors at sea can mean no one comes home. Modern researchers have sometimes struggled to fully document these traditions because so much was oral and experiential rather than written. But revival movements in recent decades have demonstrated that the techniques genuinely work. Traditional navigators trained in these methods have completed long-distance voyages using no instruments, relying solely on observation and memory. These voyages proved that the old ways were not legend. They were functional. They were repeatable. They represented an authentic alternative to instrument-dependent navigation. So what does all of this add up to? A portrait of human capability that defies easy explanation. without maps, without instruments, without any of the tools modern sailors consider essential. Polynesian navigators settled every habitable island in a region spanning nearly a third of the planet's surface. They did it through environmental observation, specialized training, refined vessel design, strategic provisioning, and collective cultural memory. They turned the ocean from a featureless void into a readable landscape. They found what others would have called unfindable. The next time you look at a GPS and take for granted that a satellite will tell you exactly where you are, remember that there was another way. A way that required more from the navigator. A way that demanded attention, memory, and embodied knowledge developed across generations. A way that worked. The Pacific wasn't empty. It was full of information. And the people who crossed it learned to read every sign it offered. That's not luck. That's not mysticism. That's a human achievement of engineering, culture, and cognition, one of the greatest the world has ever seen. Some voyages leave no written record, but the islands are still inhabited, the descendants are still there, and the knowledge, once nearly lost, is being practiced again. That's how you know it was real. The ocean remembers, and so do they.